so this lecture is not meant to be a complete overview on how to administer storage space in Oracle. It's just going to give you some ideas about some of the concepts that are associated with managing space. Unlike other databases, well, very similar actually to MySQL, but very different as well. But unlike other databases like Microsoft Access, we can't tell exactly where the database is being stored. There's no single file. So this is a server, client-server database. So on the server end, we have storage, and the storage is going to hold our data. And it's not linked to like a, my database.mbd or something where I can just take that file and copy it to a disk and upload it to my website, and then there's my storage, there's my file. So it works in a slightly different environment. So the objective is to differentiate between the logical and the physical structures of the storage environment, create many types of storage spaces, or see how to do it, configure and view storage for tablespaces and data files, and then using the undo data as a feature and looking at that, how that works. So it's meant to be, this lecture is meant to be an overview. It's not going to show you, well, it does show you actually the create tablespace and some of the other SQL commands, but it's not going to show you exactly how to manage storage. Instead, you're going to take this as kind of like an overview in terms of the concept, and then you're going to find out, well, what version of Oracle am I working with? And then what tools, and you're probably going to end up using the graphic tools or some sort of a utility to manage the storage instead. So storage structures is the internal structure of the data that the database is storing. I know, it's like a database is a database. You know, it's like, no, it's not really a good definition, but it describes the format and the structure of the physical storage. And the physical storage turns into the logical storage. So all of your tables and objects and views and indexes and things are stored in this area. You can't pin it to one file. It's a whole series of files, and it's a whole series of concepts that work with this. So the structure of every table, view, and other objects that you create are part of the storage structure. And the data you load into your tables and other objects are also part of the storage. And so information about the structure of the tables, the views, and the metadata are also in there as well. So there's a lot of different things to think about. In terms of the physical storage, yes, we're still using hard drives. So that's a picture of a hard drive. It's a picture of a disk. And it's the physical storage. We still have data files, actually, because everything on a hard drive is stored, well, they're really big files, but they're stored in the form of files on a disk. So if you shut off the database server and you look at the hard drive, you'll see the database files. Can you do anything with them? From a non-running, kind of a static viewpoint, probably shouldn't touch those files. Probably should just leave those files alone. When you bring the database back up, then you can use GUI third-party tools or Oracle tools to examine the files. How many are there? Erase files, add files. Take a file over here, move it over there, and do all your file manipulation from the database architecture and from the database tools, not from the strict file system. People get in trouble all the time when they start playing around with the files that are on the disk. The only time you're really going to do that is if you have a bad disk. If you can replace the disk with another disk, and the disk is maybe bad, but it's still booting, and you can still pull data off, you could do like a copy of the disk. That would work just fine. Take a bad disk, copy it to a good one, and then take the files and just transfer them over if you can. That would help. In fact, there's lower level tools you can actually use for that, for disk recovery and stuff like that. But that's not what we're talking about in this lecture. Instead, we're talking about the logical structure of the storage space as it's seen by Oracle. So we have data files. We also have the operating system blocks. We have the redo log files, and then we have control files. So Microsoft Windows actually has a pretty limited operating system limitation on the size of your files, actually. So does the Mac, actually, for the most part. But long story short, Unix supports bigger file sizes and supports bigger files in general, and more utilities to make better use of the secondary storage space. Classic example is the limitations on Microsoft Access, which is why people don't use Access for a full production bit database. It can only get so big, and it can't span more than one disk. So you're looking at the operating system file size limitation. So for the longest time, people used to install Oracle on NT servers because the file size limitation was larger, and you can actually kind of create a functioning system. Oracle doesn't work well on XP or 7 or 8 or anything like that as a server, which is why that Oracle Express version is such a pain. You're going to have limited file storage space. You can't run a full server off of a Windows box. It just doesn't work. If you load it on a Unix server, then you've got some capabilities going on there. So it's definitely tied to the operating system that it's running with. I don't even know. They used to make it for NT. I don't think there's any NT machines out there anymore. I'm not sure. Didn't NT kind of just die away? I don't know. But it used to run an NT, but that was limited, not as good as the Unix server environment. So what you're looking at here is this is a data file, and it has two parts to it. You see a .dbf. This is just for illustrative purposes. .dbf, .dbf, .dbf. You got a bunch of files, and they're all together in the operating system block, and they all make up the concept of the storage area. So a data file is made up of operating system blocks. Operating system blocks are stored on the physical media. So then we have this kind of logical structure look here. So this is a table space. So user table space, you give it a name. Actually, you can create a table space. Give it a name, stick all your objects in the table space. And then you can use this table space, or you can use that table space over there, or that one over there, just the same way as you create database objects. You guys are all on the same table space, which is why, and the root account's all in the same table space, which is why I can see everything, actually. But MySQL doesn't really work exactly with the table space concept. This is primarily an Oracle thing to begin with, but they call the MySQL environment is configured differently. It doesn't work with the table space concept. So from an Oracle perspective, however, this is the table space is the largest logical structure, and a data block is the smallest. So the data block is what's inside. We have two extents inside of a segment that's inside of a table that's inside of a table space. So this is looking at the hierarchy of things. And I'm going to go through the bits and little pieces, explain to you what they are, show you the queries on how to create them, and then you'll walk away hopefully with an overview understanding, but you're not going to be able to implement this. This is what you really have to go to certification training for, or you really have to have an Oracle server to actually create a table space. If you're not working on an Oracle server, you can't create a table space. It's not going to work. So to look a little deeper into the data blocks, here's our table space out here. It is the gray thing. The table space is the big old blanket. So we create a table space. We can always make the table space grow. We can shrink the table space. Think of it more like of an environment. And the bigger we make it, the more room it takes, the more room it stores, the harder it is to search for items in it. So there's pros and cons to it. And then we have the ties between the logical and the physical components. So we create segments. So here's a schema object. You created your objects, actually you all created objects, your database object. You created the database, that's an object. And then inside of the database you created your tables. Well, you automatically took advantage of the segments and the extents that already exist for you. Because you don't have that in MySQL, you have a totally different concept. In Oracle, if you were doing this, you could create your database object and then make a segment, and inside of the segment you're going to put the extents, and then you're going to put the data blocks inside of the extents. I'm going to talk about each one of these things in a few minutes, but what you're looking at is a hierarchy of components that all work together to give you the illusion that you have a dedicated disk to yourself, or you have multiple disks that are working together, and the files can span over everywhere. So if I were in Oracle, and this will not work in MySQL, but if I were in Oracle and I was going to try and create one of these using SQL, it's a create table space, and then you give a table space name. And then you have data files. So you can add multiple files. So you're going to create the table space to include the data file, because at the physical level, you're still working with files. So you make the files a certain size, and you put the files into the database, into the table space. And you can turn off the auto extend to make it grow, or in temporary versus permanent, and extent management. You're going to have a local dictionary, you're going to have a global dictionary, the logging about the activities on each one of the in the table space, online, offline, is it available to the public, is it only available internally, and then segment space management as well can be turned on and off, so you can grow the segments or have the segments fixed. So you can add multiple files, separated them by commas, And the clauses are in here, are switches I'm going to go through in the next couple slides. And it's kind of dry, so I'm just going to show you the overview of it. Just a kind of a quick introduction to tablespaces. So tablespaces and data files. Obviously the data files is what's coming up with the abstraction of the table space. So once you have a table space, inside of the table space is where you're creating your database objects. And the table space is kind of the environment for which all of the objects that belong together are going to hopefully reside. So human resources could have a table space, and accounting could have a table space. And inside you have the accounting object and the human resource object. And inside there you have all the tables and the views and the things that work with that object. So think of it sort of like a directory structure, but it's an object-oriented structure. And it's in a hierarchy. So on the temporary and the permanent, temporary is an option used when creating it for a dictionary managed, which means the information about the table space is going to be stored right there in this table space in the dictionary. The default is permanent, which as the default option stores the permanent objects such as tables and indexes and everything else instead of it being dictionary managed. So it saves more information if it's permanent, and it's going to be, well, what do we contain? Well, we're going to be around for a while. Let's do some accounting. Let's just keep track of what the table space actually includes. And then we have extent management. Well, the table space manages extents in terms of the free space that contains inside of the table space. In terms of for local, it's managed inside of the table space. For dictionary, it's managed outside in the data dictionary. So long story short, we have different places where we can store the information about the table space. If we store it outside in a data dictionary, that's what I call global, but it really isn't global, it's dictionary supported. Which means if we lose the table space completely, we still have the management for it. So we could recreate it. But we're taking in system resources and we're making the resources as a whole work slower because it has to keep track of that table space. If we put all the management internal inside of the table spaces, then as a picture, the whole system doesn't slow down the system. We can have as many table spaces as we want. But we lose a table space, we lose it. We really do lose it. All the management of it, everything's inside of it's completely gone, completely. So for fault tolerance, to have it dictionary managed brings it outside. However, if you're backing things up, then you don't have to worry about it. You lost it. No, don't worry. We'll just restore back up and we'll recreate it. We don't need to manage it internally or manage it from a data dictionary perspective. So we also have logging and unlogging, turning logging on and off for the table space. In Oracle, you actually, well, actually MySQL has logging turned on, actually, by default. So does Oracle, turns things on by default. What does that mean? All the commands you're typing in, the DML, the DDL, everything you're typing in, gives you the rollback and the commit. If you're not logging, you're not going to get a rollback. So only DML commands are recorded in the redo logs for no logging. But for logging, your DDL, your DMLs, everything, your inserts, commands, everything can be undone. So it depends on how much undoing, how much rollbacking you expect to do. So you can turn it on. By default, everything is on. You turn logging off, well, only the DML commands are logged. So if you're creating the databases and you're creating the tables and the views and everything, and turn logging on, when you're done, turn logging off, less overhead, and only the day-to-day routine queries will be logged. So the data files themselves can be online or offline. So online, actually not the data files, the table space itself can be online or offline. So online means it's available for use, offline means it's not available, it's not visible. It's like making something private or public, actually. So you can have a backup table space that duplicates another table space. Turn that one off and turn this one on and switch them back and forth. Then you have really nice mirrored table spaces and mirrored database. So one of them's having a problem, no problem. Just turn that one, make that one non-visible, and make that one visible. And it's basically the same. It's the same database. So people use table spaces for fault tolerance and for backup and for testing, where you have this object out there and it's in a completely isolated environment of its own and has the same object as an object on that table space over there. So it's duplicate. Like it has the same name, has the same tables, has the same thing. So if you like the original, and don't want to mess it up, you leave the original alone. You make a new table space. You put everything on the table, on the test table space, testing space. Then you play with it there. You like it, you move it over. Actually, you don't even have to move it over. You just change this one instead of it being the, the test server. This one here is the production server. You turn the test server into the production server if you can migrate the data over. Or better yet, you just transfer it from one to the other. So, long story short, the table spaces help you organize your backups, organize your environments for testing and for making changes and upgrades with your production environment. You don't want to work as on a production environment because your users are using the system and you're modifying and changing the system while they're using the tables. You're changing columns or you're changing information in the tables and the users are updating them. So it makes absolutely no sense to have that happen simultaneously. So you use duplicate table spaces with duplicate environments to create a more controlled upgrade environment. So the segmentation space management can be on or off, or auto or manual. So the auto makes it the management segment free space and bitmap of the table space. Manual puts in the data dictionary, has the system itself. You can come through and update things. What does that do? Well, it gets rid of internal fragmentation. So with table spaces, you got a ton of fragmentation going on. Inside of the you could actually create a lot of internal fragmentation if you create a really huge table space and you're only using half of it. Well, the rest of the space, the rest of the disks and the files and stuff that you've allocated to that table space not being used is not accessible by anybody else. So you can have it auto-manage, which means the files that are being used are kind of like, it's basically how some of the virtual machines work, where, you're not using it, then put it back. Give it back to the operating system so that the Oracle, another table space can use that space instead. Or auto-grow it. So I'm running out of room. We'll make the table space bigger automatically. Shrink it, make it bigger, adjust it. A lot of similarities with virtual machine environments. In fact, actually, believe it or not, the virtual machine environment runs the same way. If you think about it, you have another operating system installed in a Parallels or VBox or something. Usually it tells you want to create a virtual hard drive or a virtual machine. Well, that's not what you're doing with Oracle. It's almost the same thing. You've got a virtual. You don't have a 200 terabyte drive. You only have 3 or 4 smaller drives that added together gave you that big size. But your virtual machine or your image is spanning all those drives, and each one of the drives has any number of files that's being used by this space that is spanning multiple drives. So it makes it a bigger abstraction out of little stuff. So it makes it so you can create big databases out of this. So let's see what we got here. Creating a table file description must be set. Create table space command, omit the data files, and it will do it automatically. Data file clause, make the size of the data file. As I say, this lecture, I'm just going to kind of breeze through it, show you the concept, but you're not going to be creating or using these commands, and this is kind of old, and the process has been upgraded since version 7, which is what this is based on. So don't take this as concepts and not the actual syntax that you'll be using, but they're still using data files, and they're still using the size and the auto extend on and off. Auto extend on and off basically says it can grow or it can't grow. Can it exceed the file size, or are we going to stop it before we hit the file size? And then the data files themselves. So the concept is we have a bunch of data files. We stick the data files in, we call it a segment. And we take that segment, we put it inside of a table space along with a bunch of other segments. And we organize everything that we're going to do inside of there. So we can grow it and shrink it and stuff. So here's our extent management clause, where we can, an example of a dictionary managed data file. So the dictionary managed data file takes the management outside of the table space, makes it globally available. And I say globally, only within the Oracle system. But it's managed by the system accounts, so it's available to all users, and it covers all table spaces. Usually a table space has an owner to it, just like the objects, and the owner is the one who's going to be putting the objects or creating the objects inside of it. So here's an example of creating a dictionary managed table space using a create table space user test with a data file, turning auto extends on and off and stuff. So it's a matter of running queries. So to do a locally managed, you're putting it inside. So you're creating the dictionary. And the dictionary is like the metadata that's stored about the segments, which means, how do you know which data file belongs to each segment? How big are the data files? How big is the segment? How big are the extents? All that information is what's being stored in this dictionary. So if it's locally managed, it's not in the dictionary, it's in the table space. Otherwise, it could be in the system dictionary. More system dictionary information is like the dual table from system. So dual tells us basically, system date, number of users that are currently logged in right now, user privileges, all that stuff is included in there. So creating a locally managed table space, segment type. So the rest of this is kind of tedious in terms of the create table space statements, but a couple comments on the temporary table spaces. Oracle recommends creating locally managed temporary table spaces and then making them permanent. Well, what does that mean? It means that the information is going to be logged, information is going to be saved. Used for temporary segments. It's nice for testing, actually, and then if you turn the logging off, it's really space efficient. So we can have table spaces with non-standard data block sizes. Actually, you can exceed the files, you can exceed the operating system limitations, and you can do a lot of tricks to it, to make it more, make the byte sizes bigger, the blocks bigger, to make things, because you're basically managing your own abstraction of your storage. So you can have as many files as you want, and in the abstraction you can have it partitioned out any way that you want, using any kind of configuration. So there's a lot of optimization schemes when it comes to this. And actually there used to be a couple of books on this actually. Managing your table spaces. It's like, whoa, it's like I need to take an entire course on how to manage your table space. It's like, yeah, it's actually kind of detailed. It's kind of a detailed kind of concept. There's a strategy to it. Well, nowadays, however, storage is unlimited. In the old days, it was something where you only had 100 megabytes, or you only had less than a gigabyte to work with. Then you got to pay more attention with how you're managing it. But if you've got now unlimited terabytes, does it really matter? And you can and then databases, so the data itself is so cheap. The disk drives are so cheap. You just buy a lot more of them, and you don't have to be as conservative when you're using them. Long story short. Not to say that you have to worry about any of this stuff, but especially when it comes to services and cloud services and stuff. I think the MySQL servers on Rackspace. We need more space. We just ask for more space, and they give us more space. It's like, and if you're outsourcing it, that's what you're going to do with your Oracle server too. So configuring and viewing the storage here. Just altering table spaces, putting things together. Here's the coalesce actually, which means we're gonna get rid of the internal fragmentation and clump all of the empty space together so we have more usable contiguous memory spaces. So configuring and viewing it, taking this table space offline, stopping it from being accessed by users. Actually, that's an interesting thing if you really hate your boss and you're being fired and you have admin access to the database. Just take all the table spaces offline before you leave. So then everything will be, well, I seriously doubt they're going to give you access to that, especially after they fire you. So you'd have to storm out and quit on your own without them knowing that you're going to quit. Just pull the table space off, that's the highest level of abstraction. If you take it offline, it takes the entire account down, it takes everything off. Because everything's inside of the table space, so it pretty much disables the entire database from that point forward. Now the front-end application is probably still running, but no one can place any orders. Nobody can do anything with it if the database is offline. So, and then they'll be scrambling around. The DBA guys will be scrambling around trying to figure out what's wrong. They'll be checking the network connections and they'll be checking everything, and they'll go, oh, the table spaces are offline. Huh? How did that happen? Don't know. check the logs. Oh, we put the logs on the table spaces. Ah. It's not stored by the dictionary. Oh. Oh, and the logging was turned off too. Oh. Methods for taking the table space offline. Here we go. No, and there's a couple. There's normal, temporary for damaged data files, so you can replace the files, or immediately for damaged disks. You know, if you take it offline, you're basically stopping it. You're closing all the files, shutting everything down, so you can, what you really want to do is pop the hard disk out, put a new one in there, load, back up the files. You're only taking it down because, well, you're not using it when you take it down, but you want to do some maintenance or some repair on something. If you wanted to mess them up, you know, without being so obvious, you could make the table space read-only. So it can only be queried, and any type of update would cause an error. Would come through and say, nope, sorry, can't place an order, but you can check on your previous orders. Can't make an order, no inserts, no updates, no deletes. So alter, and here's the command for it, alter table space accounting, read-only. See, one line of code. That's as bad as, well, most likely the database administrator is not going to give you this unless you are the database administrator. You're not going to have this privilege to work with this unless you're a system. Well, because for the same reason why you're not going to have the privilege to drop or truncate the table either. And if you have your choice between, you're mad and you're leaving, and you have your choice between dropping and truncating, you're going to truncate. Although you better have a good lawyer if you do that, because you're going to end up being sued for damages. Or maybe a backup copy of the database in your back pocket, so when they hire you back to fix it, you can just restore the backup. So. Dropping table spaces, well, that's how you get rid of everything. You drop it. So, and then, well, if you drop it, there's rollback information. If you truncate the table space, you got rid of it completely with no rollback. So if you think if this is the highest level of abstraction, you just get rid of the table space if you don't want to take it offline. See, offline is a safer bet because then they'll figure it out eventually. And they'll be, oh, you were trying to be smart. Okay, you know. They'll figure it out. It doesn't cause long-term damages. Dropping the table space, depending upon how much rollback information and stuff is kept, you may not necessarily have everything. So you can drop the table space, include the contents and the data files, and then cascade the constraints, which means cascading constraints means, you know, if this table has a key, remove it from that table, that table, that table. Just take it all out, essentially. So it allows you to delete all the tables. So it's used when all constraints outside of the table space are referenced within the table space. So you can query the data dictionary for storage information and see how you're doing. So you say you're not going to quit your job and drop all the table spaces and go battle this out in court later on. You're going to keep your job and you want to maintain this stuff here. So you're probably going to be maybe perhaps looking at the data dictionary for storage data information, seeing how you're doing, details on the data files, seeing what percentage of them are already being used. You're probably not even going to use SQL for it. There's a ton of third-party tools out there that let you look at this. In fact, Oracle even has a nice GUI interface to all this stuff. So it allows you to look at backups and table spaces and extents and things and kind of get a snapshot picture of how you're growing. Because the databases grow, and they grow uncontrollably. It depends on when they're being used and how often they're being used and how much updating is going on. Well, you could add a lot of data to these things. They could get really big. And if they do get big, then you're taking the big data class. No, if they really do get big, then yeah, seriously, that's what big data is all about. And then you got other issues to worry about. If they get so big, you can't keep it in this structure. This structure is not so good for huge data. Well, where did huge data come from? It just happened, actually, because long story short, databases have been around for years, but people recently, within the last 10 years, actually started using them and growing them and merging them and creating big old warehouses out of them and stuff. So now that we're actually keeping everything forever, things are getting real big. So querying the data dictionary for storage data, figuring out, well, what are you doing here? How's your storage data? Making contiguous memory space by freeing up the blocks and putting all the blocks together. Kind of like what people used to do. I don't know if anyone does this anymore. Do you guys do this? Do you defrag your hard drives anymore? A long time ago, people used to defrag the hard drive. I think it actually causes problems in modern day, doesn't it? especially with solid state drives. You just want to write it once and just leave it alone. The more you keep reading and writing and moving stuff around on it, the more you're wearing that sucker out. Because there's a limited number of writes on the solid state drive. So I think the whole philosophy is changing a little bit. But people used to spend, I haven't done this in years because I haven't worked on Windows in years, but people used to spend money on semantic tools to go through and make their drive more condensed and put all the the executable files up front and all the data files at the end and all this other stuff to kind of manage their hard drives. I think it's when hard drives used to be smaller, and the access speed was slower, so it took longer to find something. If you're not going to notice the difference, why bother these days? So when things are so fast, that doesn't really matter. So it'd be nice when hard drives lose their arms. Well, they have. Solid state drives don't have arms anymore, so which is good. Which means you can't, if you toss it across the street, or actually it'll probably break. The screen will probably break on that one, but drop it down real hard if it's a old hard drive with a arm in there moving around. It's probably going to break on you. So, this is a solid state drive. There's no moving parts. It's not going to break. So, but if you stick it over a big old magnet, then you might lose all your data. So it has different problems. So anyway, overview of undo data. Undo data can be stored. So the undo data is made up of undo blocks. So it's actually, you remove the data, you just mark the blocks. So this is how it can actually be made more efficient. And then the logs keep track of what you undid. So you just mark the blocks. Not using, not using, not using. So it's kind of like there's no garbage collection, there's nothing, you just leave it alone. And then eventually, when you roll something back, it just goes through, okay, forget it. Go back. So it goes back through each one of the blocks you marked as not being used. Okay, now we're using you again. So it's still there where you came back from. Until you have committed, and then when you committed, it does its garbage collection. It goes, okay, get rid of all that stuff. It's really not going to get rid of it, it's just going to leave it alone. And make it available for being overridden next time you want to add something. So assists in read consistency, and two methods for managing it. The old way, manually create a redo segment. Automatic way, it's within the undo. There's an undo table space, so it just keeps track of it, and so we can use it over and over again. So in the undo table space. So you don't really need to know how to implement undo management or anything, but let me just give you the summary stuff here. Database structures are divided into logical and physical groups. So we have a logical abstraction that's on top of a physical media. And what the physical media is depends upon what the company can afford and what the company has put together to house this database server. And the operating system that is managing the logical and the physical groupings of components. Physical structures include the data files, control files, and redo log files. And logical structures include the table spaces, the extents, and the data blocks. It's this little, little hierarchy. There's a little bit more to the hierarchy than that, but that's kind of a simplified picture of it. Table space always has at least one data file where its data is being stored. Yeah, Tablespace has to have some sort of data file associated with it. If it doesn't, where's it going to put anything? Because it's a logical abstraction for physical storage. So there's definitely one in there. And then locally managed tablespaces use a bitmap to track the extent, the free extents in the space that's available. Where the non-locally managed is stored in the data dictionary. I didn't talk about the OMF, we'll just leave that one alone. Or auto-extending, on and off, so it doesn't really manage with that. But just to recap, the dictionary managed tablespaces versus the locally managed tablespaces depends on where the information is being kept. So dictionary uses the dictionary manager, or excuse me, the data dictionary to track. What are we tracking? The free extents that we have, the free space that we have in the extents. This is really our concern, is basically how much room do we have left and what can we store in there. So they don't automatically condense down the free space to make it contiguous. Think of coalesce as a word that's used to describe defragging, to get rid of internal fragmentation. In the locally managed, we have automatic defragmentation that goes on. And it keeps all the extents and size, and everything is in the system. So the system controlled everything. We have different types of segments. We have data indexes, temporary, rollback information. Temporary databases store data while storing the temporary tables. Tablespaces can be online or offline. Depends on whether we're using them or not. And they can also be read-only. So it's not included in the regular if it's read-only, it's not included in the regular backups and recoveries, which is actually a good point, because why should you? It's read-only, it's not changing. So if it's marked as read-only, and it truly is read-only, and nobody's updating it, then leave it out of everything else. Makes things more efficient, makes things run faster, because you don't have to worry about backing up something 100 times each day when it doesn't change. So dropping a table space with include contents destroys all of its data. That's nice. And the data dictionary views the data space, including the DBA table spaces and the DBA free extents and everything. So the data dictionary has basically all the information in it that's held throughout the entire system. Undo data gives users read consistency, being able to undo it. And automatic undo management uses an undo table space as a separate table space that keeps track of that, the blocks as they're not being used. So, anyways, kind of a brief introduction just to give you a view of and give you some vocabulary in terms of how things are managed. It's a simplified approach. There's a ton of tools out there, GUI tools, that help you do the they don't use SQL queries. They use GUI buttons to make the database bigger, smaller, adds more room to it. In fact, all the terminology is a little bit different as well when it comes to those GUI tools. So, long story short, this is how the data itself is being stored, which is different than MySQL, actually. So I'm going to stop this mini lecture